How do stars work? Well, I'm sure you've heard that stars are giant nuclear furnaces, but what does that really mean? Well, back in the early days of the universe, everything was basically just a bunch of hydrogen gas. This gas has mass, and as the laws of the universe pass, the gas will amass, because gravity. If enough gas gathers in one place, it creates a positive feedback loop, gathering more gas, which in turn increases the mass, which gathers more gas, which increases the mass, and so on. After a while, there is so much gas, and the forces are so extreme that the atoms are really close together. Smashing atoms that close together literally smashes atoms together, so they fuse. Hydrogen to helium to begin with, heavier things later on. This is called fusion. You might have heard it before. Now, some of you may be wondering, I thought smashing atoms together split them. And yes, you're correct. Just not for these nuclei, at least mostly. Why? Because the particles that exist in the nucleus have different masses. Why? See, protons are made up of quarks. These quarks have a certain amount of mass, but the measured mass of the proton is much larger. This is because there's a force holding these things together, the strong nuclear force. This energy is a bunch of gluons holding them together, and this energy varies from nucleus to nucleus. According to this chart, you can see that the hydrogen nucleus has much more mass per nucleon than any other atom. So, when these two atoms fuse, where does this extra mass go? It of course turns into energy, by Einstein's famous mass-energy equivalence. Now, looking at this, you'd expect each of these reactions to create a bunch of energy, and yeah, they do. This creates a delicate balance, with gravity pushing in and the fusion pushing out. These remain in balance for billions of years, which is exactly what's happening with our sun right now. But one day, it'll run out of hydrogen, and it will fuse heavier and heavier elements, rapidly increasing in size until one day when it reaches iron. Let's look at the chart again. Iron is at the lowest possible point. It can't fuse, it can't split. Gravity starts winning. The matter collapses in on itself. Now, with our star and most stars, you won't see a cool supernova. It'll just kind of fade away, leaving behind a tiny little white dwarf. But if the star is especially massive, it'll collapse in and supernova. If gravity is strong enough, black hole. If not, neutron star. Now, black holes and neutron stars and white dwarfs are mysteries I don't really know anything about, so I'm not going to speak on them, but maybe later. Okay, thank you for watching. Bye. Mwah.